Hi, welcome to Team 12's Artifact Review Video 3 for the ARKnee app. This is the final review video for the first semester. So, what we're going to be going over today is a showcase of our app so far, including the AR tracking. Then we're going to talk about our overall progress versus what we projected on our project plan. And then just a quick showcase of our code base, followed up by just a quick overview of our project repositories. That includes our GitHub, our Scrum board, and our Google Drive. So to get started, on the center of the screen here, we actually have a screen capture from our app, which is deployed on a Android device, a Galaxy S9. So similar to the previous review, we do have menus, and these are just placeholders, but the functionality to choose game modes and set user configuration will be implemented in these places in the future. However, if we go ahead and click Start here, we're going to launch into something that looks pretty similar to the previous artifact review videos, but the key point here is this is actually through the app and not through the webcam. So this is deployed on an Android device in our app, which is pretty cool overall. Another thing to note is we are using image targets that are our own and not pre-built ones that were from the Vuforia library. So we do have our own targets up and working and tracking just fine. So similar to before, we do have some text just to showcase the angles. One thing to note is that especially the XY angles are a lot more consistent than they were through the webcam, and this is because of the more advanced AR technology that is bundled in this Samsung Galaxy S9. We do have a little bit of work to do on the XZ calculations. We're probably going to implement a moving average to help smooth those out in the future. We also added a knee angle, which is the opening of this angle here. And then we have used a measuring device to verify the accuracy of our angles. For example, this is measuring this knee angle, which is about 205 degrees from our software. And if you actually flip this up, I know it's a little small, and read the angulometer, that'll read about 205 degrees. So we are at a very good spot with this so far, that we have we're able to capture the tracking data that we need, and we verified its accuracy, so we're at a very good spot to actually now take this data and start modeling and positioning a leg in the game. I'm going to just return to the main menu here real quick, and then we're going to move on to our code base. Let me get this out of the way here. So again, we are using Unity as the framework for developing our application. Vuforia ties in very nicely, and there's handy build tools for both iOS and Android. Now again, with Unity, a lot is going to be configured through menus inside Unity itself. However, the majority of things are still implemented in code. That's going to be in C# scripts. We're using Visual Studio as our IDE for these. And here's just a little showcase of our code base so far. Now some of these, like tilt window.cs, are auto-generated by Unity. However, the majority of these have been either modified, extended, or implemented directly by us. So for example, this class is a custom click handler that defines the behavior when click events occur on the screen. This is a utility math class that contains all of the functions for normalizing and calculating angles from the positional data. This is an object that contains and holds that positional data. This is an updater that grabs the position of the image targets, does the calculations, and then stores that in the leg position object. So we've done quite a little bit of development on getting these up and working properly. And just to touch on practices that we've implemented from our project plan, we are using a style checker called StyleCop that everyone runs directly from Visual Studio. And then when a pull request is created that includes source code changes, those are reviewed on GitHub, and we look for things like comments, method and class headers, links to relevant outside information that was used to help create the code, and you know, just coherent variable names and just good coding practices in general. We don't have a super strict guideline, but we do review the code and make sure it conforms overall. And on GitHub, we're going to go ahead and take a look at that. So our GitHub repository is private, as we need to conform to the NDA agreement that the team signed with the sponsor. And this is where we store not only the source code, but also the Unity files, the Vuforia database, and any relevant project documents, including material from the sponsor, such as assets and concept docs and everything else. So everything that is directly relevant to the project is stored on our GitHub. Again, to touch on some things from our project plan, the master branch is protected, so nothing can be merged into it from a pull request unless it's reviewed by at least one other team member. And this goes hand in hand with those code reviews. Any pull request that has source code changes does have the code reviewed. For example, on this last pull request from development into the master branch, you can see that it's been reviewed and verified. Moving on to our Scrum board, again we are using Jira. This is just a quick overview of the 3 sprints we've had, the burn down chart, and the user stories that we've worked on. As we progress through these, you can see that the number of stories that we've completed and the burn down chart drastically improves, and we're looking at taking this improvement and furthering that in the next semester as we really ramp up on the development of our app. And finally, to touch on our Google Drive, this is where we store other project documents that aren't necessarily directly related to the app itself. So for example, our meeting minutes, deliverables that we've turned in for the class, and other ancillary things. Anything that is directly relevant does also go up on our GitHub under project docs. And finally, to touch on our overall progress compared to our project plan. For our original project plan, we're actually ahead of where we projected to be, and on our revised project plan, we're just in line where we wanted to be. Originally, we were devoting this part of the semester to just research and prototyping, and we were super happy when we were actually able to get a working version of the app up and running with the AR tracking incorporated into that. We did have a very steep learning curve to overcome. Most of the team was unfamiliar with Unity, and everyone on the team didn't have any experience with AR tracking technologies. So we were really happy that we were able to get all that research, prototype on it, do some tests and cases on that, and then actually implement that into our app in a working well fashion. So we're very excited to take this momentum into the next semester and deliver an awesome product. So thanks for tuning in for the video, and we will see you next year in the review video 4.